In the last lesson, we met Redis as an in-memory data structure server. Now we go deeper on the foundation every pattern depends on, keys, and time to live. A key is the label you use to find data. TTL, or time to live, is an optional timer that deletes that key automatically. Together, they power self-cleaning sessions, expiring one-time password codes, temporary caches, and cleanup without cron jobs. Key design is not cosmetic. In Redis, you never query by arbitrary columns the way you do in SQL. You look up exact keys or iterate matching patterns. If keys are vague like data or temp, production debugging becomes guesswork. If keys follow namespaces like user42 session or cart user42, you can reason about ownership, scan safely, and estimate memory by prefix. Good naming is part of the system design. A practical convention is entity, identifier, then purpose. Examples: user42 name for a profile field, session ABC123 for a login session, rate limit user42 login for attempt tracking, and product 1001 cache for a cached product payload. Keep keys readable by humans. Avoid random blobs when a structured ID works. Consistency across services matters more than clever abbreviations. These 5 commands appear everywhere. Set stores a value under a key, get reads it back, del removes one or more keys, exist returns 1 if the key is present and 0 if not. Type reports the data structure behind the key, string, hash, list, set, zset, or stream. Learn them cold. Every richer structure still lives under a key you manage with these primitives. Del key removes the key right away and returns how many keys were deleted. You can pass multiple keys in one call. In application code, delete the exact keys you own. Do not invent cleanup that scans the whole key space on a hot path. For large values in newer Redis versions, unlink can delete asynchronously so the main thread stays responsive. Start with precise deletes, treat bulk cleanup as an ops task. Time to live stands for time to live. When you ask time to live Mikey, Redis returns the remaining seconds before expiry. A positive number means the key will disappear after that many seconds. -1 means the key exists with no expiry. -2 means the key does not exist, either it never did or it already expired. P time to live does the same check in milliseconds when you need finer resolution. Here is time to live in a real one-time password flow. Set OP user 429-38201EX300 stores the one-time code and attaches a 5-minute expiry in one command. During that window, time to live OP user 42 returns the remaining seconds and get returns the code. After expiry, get returns nil, and time to live returns -2. Redis handles cleanup. Your app only checks whether the code is still present and correct. You do not always set expiry at creation time. Expire session ABC 1800 attaches a 30-minute time to live to an existing key. PEXPIRE uses milliseconds. With set, you can also pass EX for seconds or PX for milliseconds in the same rate. Keep time to live on set preserves an existing time to live when you overwrite a value, useful when updating session payloads without resetting the clock by accident. Sliding expiry keeps active users logged in while inactive sessions die naturally. On login, set session ABC user 42EX 1800 creates a 30-minute window. On each authenticated request, call expire session ABC 1800 again to restart the timer from now. A busy user never hits unexpected logout. A user who walks away loses the session after 30 quiet minutes. No separate sweeper process is required for the common case. Cache aside is the classic Redis caching pattern. First get product 1001 cache. If you get a value, deserialize and return it, cache hit. If you get nil, query the database, then set product 1001 cache with the JSON payload and EX300. 5 minutes later, the entry expires, so the next miss refreshes from the source of truth. Time to live replaces most manual invalidation for data that can tolerate brief staleness. This is one of the most common production bugs. A key has a time to live. Someone later runs setKeyNewValue with no EX option. Redis replaces the value and clears the expiry. The key now lives forever unless eviction or a later expire intervenes. Fix it by including EX or PX on the write, calling expire after the write, or using set with keep time to live when you intentionally preserve the old timer. Keys user looks convenient and is dangerous in production. It walks the entire key space and can block Redis while it runs. Prefer scan with a cursor, scan 0 match user, COUNT100. Redis returns a new cursor and a batch of matches. Repeat until the cursor returns to 0. Count is a hint for batch effort, not an exact size guarantee. Use scan for ops tooling and migrations, not on every user request. Persist key removes any time to live so the key becomes permanent until deleted. That is useful when promoting temporary data into a longer-lived record, but dangerous if done accidentally on cache keys. Rename old new moves a key to a new name and overwrites the destination if it exists. Use rename NX when you must not clobber an existing target. Treat these as deliberate opt or migration tools, not casual request path commands. Time to live and eviction are related but not the same. Time to live is a per-key timer you set. Eviction policies decide what Redis may drop when max memory is hit, for example least recently. Used keys among keys with an expire setting. A missing time to live does not mean a key is safe forever if the instance is under memory pressure. Design hot data with TTLs, size your memory, and know which eviction policy your environment uses. Before you ship, check these habits. 1. Every temporary key gets an explicit time to live at write time. 2. Overwrites that should stay temporary include EX, PX, or keep time to live. 3. Production iteration uses scan, not keys. 4. Key names include entity and ID, so ownership is obvious. 5. Do not store unbounded growth under one key without a trim or expiry strategy. These 5 prevent most early Redis outages. Here is what to remember. Every Redis value lives under a unique key. Name it with predictable namespaces. Use set, get, del, exists, and type as your daily toolkit. Attach time to live with EX, PX, or expire so temporary data cleans itself up. Sliding expiry refreshes active sessions. Cache aside uses get, then set with EX on misses. Never rely on keys in production. Next lesson, strings, counters, and feature flags in depth.